Okay, the outline is threefold, something on new technology or relatively new trend there, hybrid manufacturing systems, something on the AM standardization roadmap, what has to be done there, what is to be done there, and AM strategic research agenda. So what is on the agenda for additive manufacturing? By the way, additive manufacturing is the official term for 3D printing, but that's just wording, yeah? Talking about standardization. So we all have seen the hype on additive manufacturing where at the moment 3D printing is on the top. This is the 2013 data. It's interesting to see what happened in 2010, 11, 12 and which things appear and disappear. But at the moment we are on the top with 3D printing at the peak of our expectations. You see all these magazines, Print Me Stradivarius on The Economist and other initiatives, the Obama America Makes things. So things are going on there. So what's in there for us? Well, we've seen a lot of applications already. Industrial applications, I think, is the interesting part for us, complementary to the home printers, I would say. So for the additive manufacturing platform, as you can see it here, we have the professional printer on the agenda. So you can see here a titanium bracket with an optimized topology. So this is the official one, the earlier one. Take out all the material you don't need and you make it lightweight. Whereas if it's still strong enough. That's the idea of using additive manufacturing. Lightweight, you only use material where you need it, so no waste, in principle. There's a lot of ifs and buts, of course, but that's not important at the moment. Okay, current versus future AM systems. Well, if you look at current additive manufacturing systems, most of the time they are working batch-wise. They have a batch system. It's a tabletop machine or a little bit bigger, but it's a batch-wise system. It builds products layer-wise, and a full bed of parts is being built. It's relatively slow, relatively slow. It's a mono-material machine. In principle, there's maybe 2 materials initiatives, but in principle, it's one material. And no composites, no inserts at the moment. So we make very nice parts, topology, shape, optimized, strong enough, but still it's going very quick. Now I'm lost. Okay. Whereas future systems could look like this. They could be hybrid systems, so combining an additive technology with another conventional technology. So why not, if you want to do post-processing by a laser, combine it in one system? That is a hybrid system. You'll see that later on. It should be at high speed. If you build a product layer-wise at a very expensive machine, you have 2 or 3 or 5 parts per day. Those will be very expensive parts. So something needs to be done there on the speed of the process in an expensive machine to make it an economic system. A multi-material system should be there. Graded is from material A to material B, a change over there. So grade of material. And you could combine different technologies, as I said, use a laser, pick and place to put something in, add sensoring, why not? And this is the trend, as this can be seen, and is also described in the additive manufacturing strategic research agenda. Some copies are out there. I'll deal with it later on as well. So, if you see the history of additive manufacturing, you saw the monomaterial additive manufacturing starting in the 1990s, about to 2005 monomaterial. Now you see some onsets on multi-material AM. You saw some parts over here. And the next step will be the integration of sensors. Well, the beauty of additive manufacturing is that you can make all kind of parts with nice shapes, metallic parts. These are hydraulic manifolds, by the way. This is a system using 2 material, whereas you can think of, if you have these ribs here, if they could be fitted with conductive tracks, they could do some kind of monitoring or so. What if you would be able to put conductivity and sensoring in a part like that as well? Not only on the outside sticking something on it, but if you build it layer-wise, you have the opportunity to stop the build, pick and place a sensor in, and continue the build. So you can have your sensorics inside, electronic sensors or optical sensors. That is the next step we expect to be done from additive manufacturing. So, thinking about the future, the products which need to be made. Of course, we have a community which is connected, which has social challenges as well. People are creative, people want to be involved, and they all want products like this. Well, at least I integrated there. Of course, these products should be integrated, should be modular, smart, multi-material, functionalized, have a high added value. Of course, all these things are very expensive. Should be environmentally friendly, should be miniaturized and integrated. They should have all things in one, like an iPad. How to build these paths? Well, by doing so, you need some kind of manufacturing building blocks, as you can see it here. The Lego as a picture there, where you can see here on the bottom side the milling, the grinding, laser ablation, cleaning, coating, whatever, pick and place. Conventional manufacturing, and on the top part the additive 3D printing, powder bed fusion, material jetting. And the idea is to combine those technologies in one system to build these products. The products we just saw, and the products which are not there, of course, because we don't have these systems at the moment. To have best of both. So the hybrid manufacturing will have pick and place, will use additive technology and use subtractive technology to use the best of all technologies. Yeah. So here you see the integration, the hybrid manufacturing, which will yield then these products we were just showing these society people. So products will be made by hybrid manufacturing. It's the idea. It's the idea of the AM platform with stakeholders, which discuss like we do today about here. What can we expect? What are the trends, etc. Yeah? That's hybrid manufacturing. So still, it can be very slow. So thinking about new concepts, you can think of a belt like that, where you have different stations, a printing station here, a drill here, a curing, etc. And the part moves on one platform and is built layer-wise. So it gets 100 layers of this one, 100 rounds here, maybe 20 pictures of this one here, and you have plenty of space of other processes which can be done along the line. You can imagine if you have space like this, you can easily pick and place a chip in or something else. And these can be additive modules, but this can be a conventional module. Why not combine both of them and to have best of both? By the way, here you can see you made a change from a batch to a continuous production, stopping the idling time of your printer. If an additive manufacturing printer needs new material, it needs to recoat, and the printer is just waiting. A waste of time. Why not printing the next one? Yeah? So you take out all idle time. That's the idea. So there you can make a big step into production speed and cost. Cost will go down, while adding functionality as well. Yeah? This was a system we built in the Netherlands as part of a Print Valley project.